Good evening, everyone. A very warm welcome to everyone on behalf of ISRO Space Tutor KIYE. I am Vaishnavi from Gokaraju Rangaraj Institute of Engineering and Technology, and I will be your host for today's first lecture of S Talks. And I'm also an active student coordinator from Kalam's Institute of Youth Excellence. And over a past year, we conducted the Aryabhatta series, a 12 journey lecture, one session every month. And the response, absolutely incredible. Students, educators, and institutions from across the country joined us, learned with us, and grew with us. And one thing became very clear: curiosity for space and technology is limitless. And that's exactly where S Talks begins. While the Arabata series corrected with you once a month, we wanted to do more. More correction, more consistency, more impact. We meet every Saturday. Yes, every single Saturday. We come together, learn, explore, and grow. S Talks is not just a lecture series, it's a platform, a community, and most importantly, a mission to ignite curiosity, to inspire innovation, and to shape future of young minds. Our theme is Space is the next destination. Let's explore it. And today we continue our journey with a very special session. Let's now take a quick look at a short audio-visual presentation that showcases the vision, achievements, and impact of KIYE. Now, the video starts.
And not waste it.
That was an incredible journey, one of an incredible journey of KIYE. Today, on this special occasion of March 28th, we are delighted to present an inspiring online lecture organized by KIYE Foundation. Centered around the theme Space is the Next Destination, let's explore it. Today's session is designed to ignite curiosity, passion, innovation among students and space enthusiasts. Before we begin, let me briefly introduce the KIYE Foundation. KIYE is a student driven initiative that focuses on empowering young minds through technology, innovation, and knowledge sharing platforms. The foundation, which is actively conducting workshops, seminars, and awareness programs to bridge the gap between the academic learning and real world applications, especially in fields like space, AI, and engineering. And today, I'm glad to host this. So let's now invite our passionate student coordinator, Miss Hansika, to share her experience in KIYE. Hansika, please go ahead.
Thank you, Vaishnavi. Good evening, everyone. I am sincerely grateful for the opportunity to share my experience with KIYE. Myself, Hansika. I am pursuing my BTech in Sri Hindu College of Engineering and Technology. Today, I feel honored to share my experience with KIYE Foundation, that organization that has played a significant role in shaping my personal and professional growth. Before joining KIYE Foundation, I had interest and curiosity, but I lacked exposure to real world learning and leadership opportunities. KIYE Foundation provided me with a platform where learning grows beyond classrooms and textbooks. It helped me understand the importance of leadership, teamwork, and responsibility. I got the opportunity to be involved in organizing major event Vigyan Vaibhav 2.0. Through that event, I learned planning, coordination, communication, and time management. I also gained confidence by interacting with professionals, speakers, and students. KIYE helped me overcome stage fear and self doubt. It encouraged me to take initiative and believe in my abilities. Every task assigned me to become a learning experience. Every challenge helped me grow stronger and more confident. What makes KIY Foundation truly is its vision to empower students and nurture young leaders. Today, I stand here as a more confident and focused individual with clarity about my goals and career. I'm deeply grateful to KIY Foundation, my mentors, and my team for the constant support and guidance. Thank you, KIY Foundation, for shaping my journey. Thank you all for giving me this wonderful opportunity. Thank you all.
Thank you, Hansika, for your dedication towards KIYE and sharing your experience with us. Now, let's make this session a more interactive. Dr. S.Somanath will soon address your questions and doubts related to space and aerospace as it is the incredible journey of first lecture of S Talks. You will be meeting and sharing your questions with him soon. Till then, take the pride in being a part of a nation that is reaching new heights in space and technology. Comment fast by saying I am proud to be an Indian in YouTube live chat and hit like and subscribe KIYE Foundation without fail. Before we begin, let's show our excitement and support. Don't forget to hit like, share, comment, and subscribe to KIYE Foundation because where inspiration meets innovation. Now, through its flagship initiative, S-Talks is where S stands for Science and Space. KIYE brings expert scientists and innovators directly to your screens, creating a platform to learn beyond textbooks and explore the future of technology and space. With a powerful vision of 52 weeks, 52 talks, and this journey continues to inspire curiosity and excellence among students. And if you are enjoying this session, don't forget to be with us throughout this journey. Let's grow, learn, and innovate together because S Talks is not just a lecture series. It's a simplified, complex concept of science and space technologies which will inspiring your curiosity beyond textbooks. It's a bridge of the gap between the students and real world applications of 52 weeks and 52 talks. Continuous learning platform featuring industry experts, scientists, and innovators. It's a beginner friendly, advanced insights, and focuses on future technologies and space missions. And it also promotes scientific thinking and innovation. It inspires students in space, technology, and research fields. It develops the leadership, communication, and professional skills also. It's a platform to interact experts and scientists. National level lecture series, for example, we have our Aryabhatta series, which is a 12 lecture long series which has been webinar with the scientists of ISRO DRDO experts. It's development sessions and workshops. Now we are going to meet our guest speaker, Dr. S.Somanath sir, soon. Namaste, sir. I am Vaishnavi and I will be your host for today's session.
Namaste, can you hear me?
Yes, sir.
Okay, please start.
Yes, sir. Here's what you gain from S Talks, which we learn directly from top scientists and industry leaders. Explore careers in space, aerospace, and emerging technologies. We build communication skills and critical thinking skills and earn certification after completing these all sessions. Now comes the highlight of today's event, the moment we all have been waiting for. It gives me immense pride to introduce our guest speaker, the one who led the prestigious Indian Space Research Organization as its chairman with brilliance, determination, and unmatched dedication. A true architect of innovation whose journey from a curious engineer to one of the most respected space scientists inspires millions across the nation. Dr. S. Somnath sir completed his BTech in Mechanical Engineering from TKM College of Engineering and went on to pursue his MTech in Aerospace Engineering from IISc Bangalore. He has been a key force behind the design and development of India's launch vehicles, playing a crucial role in the success of PSLV and GSLV missions, who has elevated India into a league of world's top space powers. He has also served as director of Vikram Sarabhai Space Center VSSC, and the Liquid Propulsion Systems Center LPSC. Two of the ISRO's most vital centers are responsible for launch vehicle and propulsion technologies. Under his leadership, India achieved remarkable milestones, including advancements in launch vehicle systems and historic missions like Chandrayaan 3, further elevating India's influence in global space arena. But more than his achievements, it is his vision, dedication, and commitment to innovation that continue to inspire millions of young minds across the country. Please join me in welcoming a living legend of India's scientific excellence, Dr. S. Somnath Sir, a symbol of excellence, leadership, and spirit of exploration. His journey reminds us that with passion and perseverance, even the sky is not the limit. We are deeply privileged to have you with us, sir, today. Sir, the virtual stage is all yours.
Thank you so much.
Thank you,
I
sir.
believe I can hear you, and I will just my presentation. Just check whether you are able to see it. Can you see the presentation?
Yes, sir, we can see it.
Okay. So I'll continue with this now. Shall I?
Yes, sir, we are looking forward for it.
Okay. So what I want to speak today as an inaugural talk of the KIYE Foundation. So you are starting a new talk series, which is going to be there on every Saturday evening, I believe, 52 talks. So the stocks, you called it, and its inauguration is happening, and I'm really happy and proud to be part of your effort. I understand that you are organizing it by the students. So congratulations once again to each one of you for putting efforts to organize this through this bringing people together and then talk about journey of each individuals and organizations so that you benefit something from whatever we speak. So I thought that I should speak about space, which I am coming from, and also what are the possibilities for youth today, and how do you can find this in many ways inspirational, entrepreneurial, learning, science and technology. I think in all domains, possibly it will be helping you. So let us look for it. But most important part, of course, is in understanding that space represents a great opportunity where you'll always see wonderful things happening, like a rocket taking off. It's always very interesting to see a rocket taking off, majestic, with great sound, great expectations, and every possibility of reaching the orbit, but also having every possibility of failing and not reaching the orbit. So it presents a huge challenging technological problem in front of you. And it is very inspirational because it is very fast, going very high. And it is the only way that human being can ever travel beyond Earth to other planets and other cosmos. So it presents a great opportunity for everybody. But the world over, you see the space is emerging very, very dramatically all over, especially with people like Starlink, Elon Musk, the SpaceX, dominating the domain, building great strategic activity with the space at this moment. And then we can see that everywhere there is a great thrust on space technology, primarily because of the importance that space has now with the domains like uh, so
Sir,
just a moment.
sorry to interrupt, sir. You can click that cross button to make it close.
I think it's
Yes.
you can see it now.
Yes,
Yeah.
sir.
Okay. So
You can make hide.
that you
You
can
can
see
click
the
on hide, sir.
pardon.
Like, sir, the below one, you will get a hide option, sir, there.
It's okay. I have done already.
Okay, sir.
So
Thank you.
what is done is that space is now a very big catalyst for innovation, technology, and nations are also declared space technology as an economic activity that it is going to drive their future economy. So that way, it is becoming very, very important. What we did in India is also equally great because our accomplishments are very significant with almost 200 and odd missions, and also rockets and satellites built in India achieved great technology demonstrations in many areas, which is you people are all aware of. I don't want to spend time on it. And we have done missions like Chandrayaan-1, which found water on the moon, which is very significant as far as we are concerned because it actually started the journey of going to moon once again. America is getting ready for sending men and women to the moon. Once again, the new rocket SLS is just getting ready for launch. The countdown is starting within few hours. That's what I understand. So this is where the world is now. So you can understand how much India made an impact in moon missions in the recent times. Then came the Chandrayaan-2, which we built a rover lander, but unfortunately this couldn't land on the moon successfully. But then we have beautiful pictures of one of the highest resolution images of moon ever taken by any craft of the world is from Chandrayaan-2. And learning from the failures to soft land in moon, we built the Chandrayaan-3. And Chandrayaan-3 made the beautiful landing. I think all of you would have watched while this was happening or later through YouTube. And this is very, very uh, again, it went sometimes. One second. Yeah, the video is running. So this landing was so perfect that it landed with a very correct velocity. Its ramp deployed, the rover came out beautifully. It went around the moon, took beautiful pictures, conducted experiments. I think this many of you would have already watched and then understood in great detail. I am very sure about it. So let us look at this video a little, 1 minute or so. This mission to moon represent one of the very complex mission because this is happening at almost 4 lakhs kilometers away. We need to have communication capability. We have to completely program it such a way that we can contact them and then get the data, visuals, commanding. So when I saw this picture, the rover getting deployed, and then it's moving on the moon, I really got thrilled to see these images. I can't just but believe my eyes. Whatever we simulated in computers coming to a reality at this time. So once again, I'm playing it for you. Possibly you would have watched on YouTube somewhere already. Now, it's not only did it actually landed on moon, it did beautiful experiments to understand the moon better. The rover traveled almost 100 meters. It conducted experiments looking at the moon regolith and finding great sense of it. We not only did moon missions, we also built reusable aircrafts, which can be becoming a launch vehicle at some point in time. You can see the landing of the craft, which we call RLV, reusable launch vehicle, which was a fully autonomous landing, the first time ever done in this country, which was also successful, repeated many times. But this is not actually coming from orbit. It is coming from somewhere midway. But we will be soon building the craft which will go to space and then come back. And this is not meant for human beings to travel now. It is meant for fully autonomous operation and for cargo missions. Because of such accomplishments like Chandrayaan and many others, now the government has given a big vision for us that you should build a space station called KIYE Presentation Station. We should continue our moon missions and land human being on the moon maybe much before we reach 2047. When we celebrate our independence, the 100th independence, much before that, an Indian should be on moon. For that, whatever technology required, infrastructure required, we have to develop. The government is fully supporting us. Now, for example, the space station called KIYE Presentation Station is such a great opportunity for us to drive areas like microgravity research, biology, material research, etc. So I want to tell young people that those who are going to learn science and technology, please look at it as a possibility to become an astronaut and do some research in the space using KIYE Presentation Station. Similarly, another mission called Aditya L1 was our India's first observatory to go to Lagrangian point L1 and then do measurements on sun, using 7 big important instruments, including a coronagraph, ultraviolet imager, high energy and low energy X-ray meters, plasma measurements, magnetic particle measurements, etc., etc. So this is giving wonderful results at this moment. And this journey was a really challenging journey for us to build and launch it very safely and successfully. Similarly, another mission which happened sometime back is a Mars orbiter mission to go to Mars, image the Mars in great detail. So you look at the picture, such a beautiful picture of Mars, which is made by Indian cameras. And this is an assembly of so many images to produce such a three-dimensional field of Mars. You can see the Mars color camera even brought out wonderful images of Mars. Today, the best of images of Mars are coming from an Indian satellite, the Indian color camera on board Mars orbiter mission. So this gives you the atmosphere, very thin atmosphere of Mars is captured beautifully, which is red in color because of the various constituent elements, especially carbon dioxide and dust. You can also see the Mars color camera beautifully captured images like the Phobos and Deimos, the natural satellites of Mars, very beautifully captured, which is having orbits around Mars in a very interesting direction. So this is a very interesting, 2 important natural satellites of Mars, which was captured by our Mars orbiter mission. But the new point which I want to tell you today is more about the changes that are happening in space, primarily because of the various activities globally. The communication domain, which satellite used to work, is now moving from geostationary to LEO. There are a lot of constellations being built, and a lot of Earth observation data goes into data analytics. And there is a lot of data which is going into strategic defense, surveillance, safety, IoT, drones, etc. And a lot of AI is also coming into space. Meantime, when we work on interplanetary travel, human travels, etc., and a lot of new technologies are coming into space. This is what I want to explain to you, and look at how you can use it for your career, research, and employment. Globally, you can see new generation of satellites are coming. Manufacturing in space is starting. Small satellite constellations, IoT, new areas like space situational awareness, space tourism, all are becoming very important domains. Equally important is defense. There are strategic use like early warning satellites to look at missiles, incoming missiles. You can see that in the recent wars, this is used left and right. Similarly, destroying anyone else trying to interpret us through jamming, spoofing. We have technologies for that. Similarly, space domain awareness, specifically if somebody is operating satellites to destroy our satellites, we should be aware of. Similarly, also we have domains and technologies for looking at sea, vast oceans, to track ships and submarines in a big way. While all these are happening, we are also building new missions to explore. For example, going to moon has been a major topic. We are also developing our Mars lander. Also, Chandrayaan 4 and 5 is going to come up to be launched in our future rockets. And also a mission to go to Venus is also going to be built, and currently India is building all of them. And we got approval a few years back, and that work is currently progressing. One of the interesting work we did recently is the work with America, the US and India jointly built a satellite called NASA ISRO Synthetic Aperture Radar. So this is very important historically because NASA has been a supporter helping us. Now this is the first time that we are standing shoulder to shoulder with the great giants like NASA to build a satellite to look at Earth and then give us significant data for various purpose, especially looking at precise measurements of tectonics, especially green cover, water stressing, and many other things can be measured using the radar technology which is incorporated in the satellite, which is jointly built by India and America. We are also going to build satellites in large numbers in the coming days, possibly hundreds of them, through various industries. And this is a very important point. Earlier, all satellites were built by ISRO only. Now, more and more satellites will be built by industry. ISRO will also build satellites, especially the high-end satellites like Chandrayaan. Complex satellites will be built, but very large pool of small satellites will be built by private companies, which is already happening. 30 satellites are being built by private companies for ISRO at this moment. Equally important is building of rockets by private companies. PSLV has already been handed over to industry, and rockets like SSLV technology transfer is happening in the process of building. The future rockets also will be handing over to the industries. But while India develops bigger rockets using through ISRO, private companies are building their rockets, like which I'll speak to you a little later. So really, we are going to have many rockets in India, both from ISRO, private industry, and startup companies. Another interesting area is called reusable technologies, where a lot of such technologies are being built. I showed you the landing, but equally important is rocket itself coming and landing using vertical landing technologies, which India is trying to develop now through the rocket called NGL. And India is also developing new technologies like green propulsion, nuclear propulsion, hybrid propulsion, etc., which are becoming in new areas for R&D research. When you people start doing your engineering or higher studies, you can use these are potential areas for working on future technology development in propulsion area. Equally interesting area is called additive manufacturing, especially with metal. Earlier, all the fabrication was metal removal practice. Now, the most of the manufacturing you can do using additive metal methods. I request you to study this. What is metal additive manufacturing, and understand how this is going to change the engineering manufacturing sector substantially in building complex products. I think you would have heard about 3D printing. Same thing is 3D printing is called metal additive manufacturing when you use metals for bringing rocket engines and parts. Another interesting area is called space domain awareness, where looking at the satellites, which are in millions, and we need to track them, monitor them, measure them, and then find out why it is important to look at them, and then protect our assets without any damage. Also, debris to be handled, tracked, recover the debris, etc., becomes part of this activity. And you can see that there are a lot of companies now building small satellites. And this, in India itself, now almost 6-7 companies are building small satellites. And this is very important for country to build Alpanarpada, including building this satellite. So I advise you to look at these companies, which I am going to present you. Another interesting area is called a fusion of technologies. Communication, Earth observation, navigation, timing, and service are all integrated into one satellites, and they are able to provide such services, especially digital technologies, smart manufacturing, connect vehicles which are autonomous vehicles, smart cities, etc. This connection is happening. A lot of companies are also building supply chains in the country, and I know many of our young people are employed in this manufacturing, especially building technologies for satellites like cameras, radars, solar panels, propulsion systems, sensors, composite structures, thermal control systems, electronics products. And many of this work is to happen in India so that we can become one day a big supplier of this to the world. I think this is one of the goals all of us should have. Artificial intelligence and machine learning, I think all of you are very keen to learn, study. You know that it is very much used in space also, especially in planning the trajectory, operations, autonomy, space traffic management, digital twins, humanoid robots, data analysis. Everywhere AI is being used in space also. Possibly in coming days, design also will be done by AI. Equally interesting domain is robotics, automation, in-orbit services. Robots. Now we have more robots to go to space now because we need to service them, refuel them, rendezvous and docking we have to do, bring back the satellites sometimes in case they have damage, or dead satellites have to be removed. I think all of this requires a lot of robotic activities. We are also developing world over technologies like software-defined radios, quantum key distribution, optical communication. These are the new three things which are very, very current and very active in research. Software-defined radios are very important, where everything can be programmed using software. Possibly your mobile phone, if you have a radio, that's a software-defined radio. Similarly, optical communication requires light, using light that you can communicate from space to Earth. Quantum key distribution is used for protecting our communication network using quantum encryption. So all of these are becoming part of the satellite space network. Electric propulsion, I already mentioned, is slowly picking up in big way. Most of the satellites today being launched by Elon Musk contains electric propulsion. And India is also going to launch a big electric propulsion satellites in a few months from now. And there are new propulsion technologies, as I mentioned, which is going to be very interesting for all of you, especially electric propulsion, green propulsion, and nuclear propulsion. Please watch out for such domains for potential research possibility. In application domain, you can see India is a very strong application builder to help governance, national resources management, economy activities, infrastructure support, etc., etc. So there is a lot of work happening in this. Let me explain in a few slides which are those areas. Especially data-driven decision-making space is very useful. Data collection, processing, AI-based analysis, geospatial data analysis, surveillance, and connected with the communication networks becomes very important for space. And this is where new software-trained people will have job opportunities. And similarly, in imaging, a lot of imaging satellites are being now built, right from imaging from geostationary satellites to very low orbit. And this becomes very important for people to understand real activities on day-to-day basis, especially for security purposes. One of the important use that we have for space technology is to support agriculture. This slide shows you how agriculture technologies can be supported by space, especially in the insurance domain. So we have an organization called S.Tech, which is working in yield estimation and supporting farmers in case they face problems in insurance claims. So this is across the country, this is now operational. Krishi Darshan is a system that is helping agricultural estimation, especially crop yield estimation. We also support in terms of cyclones and many other support systems which are required in case of disasters. Similarly, Navic, though there is some news that it is not working, some of them are not working. I think it will be replenished soon. But this is an Indian-owned navigation system, which is important for us, especially to support the strategic users. It will come to civilians little later when our new signal structures like L1 comes in. Currently, the satellites are having only two signals called L5 and S, which is a very restricted one, and it is useful only for defense. And I am sure the coming days, L1 signals will be built and launched in numbers. And that will make your mobile phones and other vehicles accessible for Navic. And Navic already using services for ship communication, vessel communication, and many other services, including disaster communication. Fisheries is a big user of it, etc. So it's already not only providing timing services, it also serves in many other sectors. Let me quickly look at the private space sector and close my presentation. First is about emerging private sector. A lot of companies are coming up in space today. Two rocket companies, I think you have heard of them, Skyroot and Archegol. Similarly, many other companies who are based in across this country are well known, and they are building rockets, satellites, applications, technologies in Indian companies. For example, Skyroot is an interesting company which is building a rocket at Hyderabad. I think they have already made their rocket ready for launch. You will soon hear about their launch schedule from Satish Dhawan Space Center. Agnikul is a company which is building liquid engine based rockets at Chennai. Their company was incubated at IIT, and their biggest news is 2 days back was they're studying one of the biggest engine for the booster for a very long duration. Satshore is a company which is based in Bangalore, building satellite application for agriculture using satellite images. Very interesting company, and now it's grown very big and employing a lot of young people. Pixel is a company based in Bangalore, building high resolution images, especially hyperspectral images. Hyperspectral is a special imaging, not just like optical imaging. It gives you much more information from the images that you can identify materials and other various factors using this imaging technology. Of course, there are companies like Kava Space will help during Operation Sindoor by providing satellite data. Companies like Galaxy in Bangalore currently is building radar and optical combined satellites. Their first satellite is going to be launched within few weeks. Similarly, companies like Dhruva in Hyderabad is building satellites, solar panels, and various ground station infrastructure for supporting space companies across the globe, including multi-billionaire companies. Bellatrix is a company based in Bangalore, building electric propulsion systems and thrusters, and they have been incubated in Indian Institute of Science. Now they have moved out and they are building their systems, especially bigger satellites like space ducts, etc. Dikantara is again a company which started, I think it's Bangalore, Hyderabad, Ahmedabad, and they are now set up their facilities to look at space intelligence, tracking and looking at satellites and then giving intelligence to others. And they have got their contracts even from US for their defense to look at how using space technology, space-based instruments, they can look at other satellites and track them. So there are a lot of such companies that have come up in the recent times in building rockets, satellites, and applications. So for you people, the biggest challenge today is to address these following points. One, of course, is the cost of building rockets and satellites have come down substantially. Still, it is very costly for anyone to build. So how do you bring down the cost substantially is a bigger question. What technologies you can build to bring down the cost, such as the low cost reusability, new materials, new manufacturing processes. Second issue is the constellations. When you build big constellations, how do you manage them, build them in large scale, operate them? How do you bring in autonomy? And because of this space, there is another new area called conflicts are coming. So world space order, space-based systems are coming, and there are a lot of opportunity for people who are in the even in the domains like law, policy to become business to get into this domain. Equally interesting is the science domain, where you look at building new instruments like X-ray, gravitational observatories, electric-powered propulsion, and looking at exoplanets, dark matter energy. So fundamental science also, a lot of work can be done using space. And space is also a base for energy, harnessing, commercial exploitation of minerals, asteroid exploitation, etc. And finally, space is an interesting place for human being to go, stay, create colonies in Moon, Mars, and in robotic and manned habitats which will be created in space. So in all these areas, space is very interesting domain. So I advise you to look at it, study very well, look at your passion and work for it to gain your ideas into space technology. With this, let me wish you very, very great journey. Look at that India is going to moon, India is going to go to the orbit using our rockets. Your life also will travel a great journey after understanding what are the work that we do, what are the possibilities in space, and finally finding your place in space technology, science and technology, and your work will become a great inspiration for all of us maybe many years later. So all the very best to you for listening to me this, and I will just wait for any questions that will come, that will be asked by you. Thank you so much.
We sincerely thank Dr. S.Somanath sir for sharing such a deep and insightful knowledge on the Moon, Mars, and missions like Aditya L1. His thoughts on strategic space capabilities, emerging propulsion technologies, vision exploration, Venus exploration, and innovations like NAVIC and reusable rockets, Agnikul, emerging NGES are truly exciting and inspiring. This session has sparked great curiosity in us. We are eagerly and wanted to learn more and to explore further in the field of space, science, and technology. Thank you, sir, for the deep insight and inspiring talk. Your words have inspired us to believe that age is no barrier to innovation and that we too can take bold steps towards building something impactful. Your words add value to the young mind's future. Now I request our guest Dr. S. Somnath sir to take few questions from the students and our audience. We now open the floor for the short Q&A session. If you have any questions, please drop them in the YouTube live chat and we'll address a few questions right now. Sir, in meet we have Hansika sir. She want to present her question.
Yeah.
Hansika?
Good evening, sir. Myself, Hansika, sir. I'm from Srindu College. I have a question for you, sir. Um, how
Go
was
ahead. Go ahead.
Operation How was Operation Sindoor carried out, and what were the challenges faced during the operation, sir?
See, I was not part of the Operation Sindoor or anything. I know it is done by our defense agencies, and I don't have the privilege to speak about it at this moment. I can only say a few points that how space technology was useful for operations like this. For example, now you know that in such conflict situations, we need to gather a lot of information from the field, and collecting information is very difficult. And especially using aircrafts, you cannot image because they are under threat. So using space technology from satellites, both in optical and radar. Radar is important. You are looking at night time. You can identify objects much more clearly in radar. And similarly, cloud-covered area, etc. So our fleet of satellites, both optical and radar, were used to scan that area and collect a lot of strategic information to the forces, which use their force to analyze on what the identifying targets, looking at the damage done, the troop movements, etc. So this information was fed to the military command system, and they were acting based on that. So all our missions were planned using such data sets which were available prior to and after while this was happening. And I want to also tell that this support for this came from Indian satellites as well as from foreign satellites as well, which Indian companies were made use of for this purpose.
Thank
Thank
you,
you.
sir, for this valuable information.
Sir, we also have Sai Vaishnavi today. She want to present her questions right now.
Okay.
Good evening, sir.
Sai, yes.
I'm
Good
Sai
evening.
Vaishnavi. I'm pursuing BTech in Srindu College of Engineering and Technology, sir. Sir, I just
Go ahead.
want to know that which technology do you think will shape the future space technology and exploration, sir?
Now, there are many technologies that goes into space technology. I talked a few of them. For example, propulsion is the key because propulsion has been traditionally chemical propulsion. So new methods of propulsion like electric and nuclear becomes very important. So that is very important. High temperature materials very important. Reusable technologies is very important. Another is at manufacturing methods because today rocket manufacturing takes a lot of time. So we cannot build a rocket in 1 day, 2 days time. So how do you really build like that? How to build new technologies for manufacturing? Similarly, reusing rockets takes a lot of time. So how do you break down the time to reuse? Like an aircraft landing and taking off, it takes only 1 hour to refurbish and go. So can we build rockets like that? So these are the questions which are going to change in the rocket side. In the satellite side, there are many technologies which came, which includes software-defined radio, electric propulsion, reconfigurable software satellites, quantum and optical communication networks, and self-arraying satellites, robotics. All of these are I already explained. Thank you.
Thank you, sir, for your valuable information.
Sir, we have question from the YouTube live chat. So there is a boy called
Yeah.
Sritan from Siddhartha School. So his question is, in microgravity conditions, how do astronauts control their movement and avoid floating away?
You cannot avoid floating away because in microgravity control, domains that you do not have a reaction possible because your mass is, you won't feel it, your weight is not felt. So because of that, you have to use restraints. So when you move, either you float and move or you move on a controlled manner by using grips or holding. So astronauts use many things. They use methods to hold their feet to the grippers or hand to the grippers or body to the grippers, or they use rails to move from one place to another. So for movements, you need to use some methods to react, and even to move, stop your movement, you need such reactions. So microgravity gives you a complex situation. So astronauts are trained to handle it. So for them, that becomes natural. So essence of this in Earth, when you move, that you have a weight which happens on your leg, and you are always reacting to it. And when such reactions are not there, then friction is absent. Even to start a movement, you have to push against a wall, really. So there are many such interesting things that will come up when you go to zero gravity.
Thank you, sir. Sir, with your permission, can we proceed with the questions?
Yeah, I need to close maybe in few minutes. You
Okay,
can
sir.
take a
We
few
can
more
wind down.
questions. Yeah,
Okay,
yeah.
sir. Sir, okay, sir. Thank you so much, sir, for encouraging young minds by giving answers to their questions. And I also thank each and everyone who showed interest in today's session by asking questions. As we come to the close of this remarkable session, I like to invite Ms. Sai Vaishnavi to present the vote of thanks. Ms. Sai Vaishnavi, over to you.
Thank you, Vaishnavi. Respected dignitaries, teachers, and my dear friends and students, a very good evening to everyone present here. Myself, Vaishnavi, and I feel extremely honored to stand before you today to deliver the vote of thanks on behalf of the KIYE Foundation and pursuing my BTech in Srinagar College of Engineering and Technology, along with the entire organizing team of the S.Talk lecture series. First and foremost, I would like to express our heartfelt gratitude to Dr. S.Somanath sir for his valuable presence and inspiring words. Sir, your insights about space, science, and technology have truly motivated all of us. Your journey and achievements are a great source of inspiration for students like us. So, your words have truly ignited scientific curiosity among our students and encouraged many teamers in the field of space science technologies. We are deeply grateful for your time and effort in sharing your knowledge and experiences, sir. Your journey and achievements have encouraged us to dream big and aim high. I extend my sincere thanks to our organization for arranging this wonderful session. Special thanks to our teachers and coordinators for their continuous support and guidance. I also thank all the participants for their active involvement and enthusiasm. Your presence made this event more meaningful and successful. We are thankful to everyone who worked behind the scenes to make this program a grand success. Once again, thank you, sir, for inspiring young minds like us. We hope to carry forward your words and contribute to the field of space science and technology. This session has been a powerful reminder that space is the next destination and we must explore it together. Before I conclude, I warmly invite everyone to stay connected with us for our upcoming initiatives. Join our WhatsApp channel and I am requesting to subscribe our YouTube channel, follow us on Instagram for new updates. Let us carry forward the legacy of Aryabhatta and S-Talks, Dr. APJ Abdul Kalam by nurturing scientific temper, encouraging innovation, and building a knowledge-driven future. Once again, thank you, sir. Jai Hind.
Thank
Thank
you, sir,
you. Thank you
for
so much,
joining us
Jayhin.
today.
Bye bye.
Your presence have truly inspired and
Thank,
motivated all of us. Thank you, sir.
thank you so much.
Yes, that was Dr. S. Somanath, sir. And on behalf of everyone, I extend my heartfelt gratitude to Dr. S. Somanath, sir, for joining us today and inaugurating the very first lecture of S Talks. Your inspiring words and insights into space and science have truly ignited the powerful tone of the series. It has been an absolute honor for me to host this session in your presence, sir. Sir, we sincerely thank all the motivating young minds to dream big and reach for the stars. And I also thank everyone who joined us today. Thank you for being a part of Lecture 1 of S Talks, and let's continue this exciting journey together as we explore new things in science and space. As I request everyone to subscribe our YouTube channel, KIYE Foundation, for future sessions and also joining our official WhatsApp channel for updates and announcements. S Talks, S means Science and Technologies. It is an initiative dedicated to inspiring young minds towards space and aerospace and futuristic technologies. This is not just a lecture series, it's a mission to ignite curiosity and shape the future. Let's stay connected, stay curious, and keep reaching for the stars because truly, space is the next destination. Let's explore it. Have a wonderful evening, everyone. Jai Hind.